can replace it by an array list. Okay? And inside that array list, each time I want to add an observer, I add that I get it, and I add it to this O, to that vector or array list. If there is any change, to that observer, I call this method, notify observers. And that method will loop over what? All the observers, and will send them messages. We'll call methods in them. Okay. Assuming they are in the same package. But there is a major problem here. Problem number 1. All observers of the same type. If they are of different type, this is not doable because you can't just start, or you don't know where to switch because you have to do the casting. You have to know what object type, if it's then casted, if it's then casted. So you have to have a long list of if statements, right? Picking on the different types of observers and then cast it, then call that object. That's interesting. The other problem is, what if I add in real time a new observer and I don't have the instance already declared there? So that won't work. The third is a big problem in software development, which people tend not to like. They don't want something called hard coupling between classes. Okay, I hope you arrived to that principle. Object-oriented principles. Hard coupling, I mean, now those observers are hardly coupled. They are tied with this class. It's calling it hard coupled. I mean, obviously, this class, in order to call those observers, it will need access to them. It will need their instances inside, right? That is hard coupling between those two classes talking to each other. Okay, tied that code. And we're trying to break it to make sure our object-oriented software development is light. Okay? And it's not producing lots of dependencies, therefore lots of complexities when we grow the system bigger and bigger. We try to favor implementation over inheritance. We'll come to that principle in a minute. So therefore, they've invented something. It's already in the JDK 0.8. So this is something you use. There is a design pattern called the observer design pattern. And the observer design pattern, you've got a class already implemented for you called the observable in the JDK 8 under the util library, and you've got an interface. Interesting. An interface called observer. Okay. Now, if I have a subject, I'll talk about these principles in a minute. If I have a subject here, and this subject will be observed later on, okay, it will be an observable, I'll need to extend the observable. Extend here, I'm inheriting the features. So I can add observer. I'm not worried at all about how do we add it, the different types of those objects, etc. This is all done for me in here. So I've reused the functionality, all these problems have been solved. And I can later on, if I want to notify observers, notify those guys here, I just call a method notify observers. So, and there is no hard coupling between this observer and this subject. This could be 100 observers. Okay. The interesting implementation, let's follow. Those at the package level are coupled. Okay? Those are hardly coupled together. Yeah, there is a relationship in here. But that is not your problem. With your system, you don't have a hard coupling between those and this. Okay, that is another nice development. You can just add them here, and they'll go here, and when you call notify observer, it goes this way, rather than this way. Okay. More. There is a principle, object-oriented principle. I tend to mention them here rather than explore them. Design patterns, they're supposed to build, and that is the building upon, and you will notice this as you go. They're supposed to build upon good object-oriented principles and also upon the basic object-oriented principles, and these are called good object-oriented principles, and go beyond them in experience. You will start noticing that as we go. So there is something called open closed principle. It's open for extension, yet closed for modification. That's great. So this is now, you can extend the functionality, but you can't change it. That's we adhere to. And the nicer one is programmed to interfaces rather than implementation, which we see it under the observer. What does that mean? It is favorable in Java to program to an interface, to implement an interface rather than extending a class. Because if you are inheriting through an interface the functionality, we don't call it inheritance, to be true with you, under expert software development. We call it if you plug into the functionality, because it's a plugging rather than inheriting. If you're plugging into the functionality through interfaces, it still give you lots of freedom, because you are in Java allowed to inherit only one class, in addition to the object class, which is by default inherited in every single class you create. Okay? But you can implement many other classes. Classes, is that right? Interfaces for the recorder, not classes, because that's a major problem. Okay, so you can implement as much as you can interfaces. You can plug into them, I call it. Okay, so it's a straightforward solution then. If you are implementing this system, you just, under the subject, you extend the observable. For the observers, A observer, B observer, you just implement observer in that class. And then, in the subject, you can call add observer, because you've inherited add observer already. And you pass the object instance, and that's it. You don't do anything more. When you want to update those observers, you just call method notify observers, and it will call an update method in every observer implemented that interface called observer. So A observer implemented an update method. That subject, through the observable, will call that update method. So when we, the implementation, it's not there, we'll see it in the lab. When we implement the observer A, for example, for that subject, we have to write a method to override the update method. And that update method will be called automatically once you call the notify method. So it will go up through the system. It will go every update method in every subclass. A class that implemented the interface. So every, for example, here, this is the subject. Once you want to add this, you pass this instance to add observer. The subject will add it above here. Then, if you want to notify that observer, and those observers 1, 2, 3, 4, 5, you just call notify observers. And as you can see, every class implemented this interface should overwrite a method called update. And where that update method is going to be called, you don't call it. It will be called in every subclass that implemented that interface. Does that make sense? Ready for you. What you do really here, I'll stop here. I'll emphasize it in the next 2 minutes. What you do really, observable is already there. It's got more method than just these three, but just want to highlight the important one. You extend that observable class, extend it, done. Now, if you want to add observer, you call add observer and you pass the instance. Done. Added. Maintaining that array list is not your problem. Maintaining the differences of those instances is not your problem. Okay. Obviously, it's been resolved by the interface. Okay. Then, if you want to send the changes in the subject, you call notify observers in the observable. Then, observable will do the job for you, moving over the array and notifying those observers. It's the observable job, not your job anymore. How it's done? If you've created an observer A for that observable, which you implement the observer interface, you'll need to override that method. So therefore, later on, every method within all, if this is 1,000 classes of different types, as long as they've got the update method within them, these update method will be called if this subject calls notify observers. That's it. And the arguments within that method update, there will be an argument pass. You can pass a string, you can pass other types, and you can pass objects into it as well. That argument will be received at the update method within those subclasses, and you can then do whatever you want with these data you are receiving. If you are receiving string, if you are receiving object, then you cast it, you do whatever you want, etc. Does that make sense? That is the simplest example I could give. We'll look at other examples as we go. Any question?